Hello and welcome to MTI 320 webinar. My name is Mehdi Behnami, Product Marketing Director at Movella. I'm here with my colleague, Gies. We are going to present this webinar to you. Today we'll present it to you in three parts. Part one, 10 to 20 minutes or 10 to 15 minutes introduction to Movella. I'll cover that. Part two, 25 to 30 minutes is technical session. Steven is going to talk about MTI 320 and its use cases in mobile robotics, especially in AMR and AGV. And the last part is Q&A session, about 10 to 15 minutes. Please submit your questions using the tab, the questions tab on the right-hand side at the bottom. And please don't use chat to submit your questions. And also, we have handouts and also leaflets under the apps tab. As you can see, if you go there, you can download the handouts and the documents. Okay, so about Movella. Our mission is bringing meaning to movement. That's what we do, and that's what we been doing for the last 23 years. We have 200 plus dedicated employees. We are leading innovator in 3D motion tracking technology since 2000. We have a rich portfolio of patents in this field with 180 patents. We have a global footprint with offices and operations worldwide in US, Netherlands, Canada, China, India, and Brazil. We are also publicly traded company on NASDAQ. Quality assurance, we are ISO 9001 certified. And as you can see on the left-hand side, we have our office location in Netherlands shown in this picture with all the employees in that office. And the four pictures at the bottom shows our focused or target markets, marine, autonomous mobile robots, mainly outdoor robots, as well as warehousing or logistics and smart ag. Core technology and business units. All our technology is based on the sensors that we have listed on the left-hand side. Gyroscope, accelerometer, magnetometer are the core sensors for all our sensor modules. Depending on the application, we can add other sensors to this base platform. We can have GNSS or RTK receivers. We can have barometer or pressure sensor, basically, and we also can have camera. But the heart of Movella's innovation is our sensor fusion. So sensor fusion is a key basically feature in any type of motion sensing. Basically, we fuse the data coming from all these sensors to make a meaning out of these movements or motions captured by these sensors. We can leverage this type of information in other markets such as entertainment or sports and health. That's why we have also wearable type of sensor. You can see them on the bottom right. But today we're going to talk about our industrial grade sensor modules, MTI series, which you can see some of the packages in this picture on the top right. So MTI series portfolio by technology. We have 6 different categories of devices. Let's start with the simplest one, which is, we call it IMU, Inertial Measurement Unit. Gyro, axle, and magnetometers are the basic sensors used in this module. It outputs raw data, but this raw data is calibrated. Next to that, we have VRU and AHRS, which basically are orientation sensors. VRU stands for vertical reference unit, sorry. Roll, pitch, and unreferenced yaw, basically that's what we provide. And for AHRS, attitude heading reference system, we provide role, pitch, and reference yaw, which is basically the magnetic pole of Earth. That's what we are basically using for the heading in AHRS. So the next three sensor modules, we are using GNSS signal and other signals for outdoor, mainly navigations. GNSS INS stands for Inertial Navigation System. In addition to roll, pitch, and yaw, we can provide 3D position, 3D velocity, as well as GNSS time. At this point, our accuracy is at a meter or a few meter level accuracy for GNSS INSS, and this is basically this is based on GNSS signal inaccuracy. So it's inherited to GNSS signal, but we can make it better by having the RTK correction signal, which is the next set of devices we have. We can bring down that the meter level accuracy to centimeter level accuracy and give you the same 3D position, 3D velocity, and GNSS time. So the last group of products, we use camera in addition to GNSS signal as well as RTK to give you the same level of accuracy, but at the same time, in GNSS denied environment when there is no GNSS. So this navigation needs to be done by using other sensors such as IMU or camera. So we provide that basically, we provide camera vision to navigate when there is no GNSS signal. That normally happens when there is no, when you go, for instance, under a tunnel, or when you are in a big cities and with the tall buildings, there is no GNSS signal, and for navigation you need to rely on IMU and camera data. And my colleague Steven is going to talk more about these categories and the products that we have in these in our portfolio. In this slide, we outline the typical in-house IMU design process, highlighting its complexities and resource requirements and associated risks. On the right-hand side, as you can see, it starts always with sensor selection, but then you go to decide what type of MCU or how much processing power you need based on the sensors actually you choose, because if you have camera with the image, you need some image processing, you need other sensors. So when you want to decide about MCU selection, you need to also think about what type of sensor you already chosen. And it goes on and on. There are multiple steps, and it goes to sensor fusion. You need to sensor fusion to develop your sensor fusion engine, and manufacturing and production. And at the end, you need test and calibration, which is very important. Doing the calibration on this type of devices requires a lot of know-how, and basically it takes a long time to master. So basically on the left-hand side, what we are showing that this type of design requires dedicated engineers and resources, which are going to cost money. There are some design risk involved because the learning curve actually is very long in this type of designs. But by using our plug and play technology or devices, you can take out this risk out of your design, and you can go to market faster. So the time to market can be shortened by using our devices, plug and play devices. I would like to give the floor to my colleague, Steven Gies, to continue on the technical section.
Thanks again, Mehdi. My name is Steven. I'm a product specialist at Movella for nearly 6 years, specifically for the MTI series portfolio. And today I will guide you through the second half of this webinar, where we focus on the MTI 320 and more the technical side of things. So let's see if I can move the slide. Yes, there we go. So before we really dive into the MTI product series, I want to take a small step back and have a look at why you would actually need an IMU or an MTI product in a mobile robot application. And I think we can summarize that question, or the answer to that question, in one small term, and that's to increase safety and reliability of your robot system. And what I mean by that is mobile robots have become more and more intelligent. They've been equipped with more and more different types of sensors. And you can actually see a list of those typical sensors on the bottom of this slide. And the purpose of all of those sensors is to navigate or to localize the vehicle in your warehouse or in wherever you are using this robot application. Often combining multiple sensors together using SLAM algorithms or other types of algorithms. And the MTI or the IMU product plays a vital role in this because many of these sensors, such as cameras or lasers, LiDARs, radars, they are used to sense the environment of your vehicle. So they try to find recognizable objects. They try to find out where exactly the MTI or the robot is located in your application environment. But it also has downsides. So if your camera or your LiDAR gets blocked by objects, or if for whatever reason the data is not processable, then you need to rely on the movement of the vehicle itself. And that is what we really provide. In short, MTI products provide information on the what we call the ego motion of your vehicle. And well, that can be the 3D orientation of your vehicle. So I'm talking about roll and pitch and heading, but also the velocity, the acceleration, and other parameters of your vehicle in 3D space. Those parameters and this information is really vital for your navigation algorithms. In addition to that, an IMU or an MTI can be a backup for many of these sensors. For instance, for wheel encoders, which measure the revolutions of the wheels of your vehicle. Those give you an indication of how far your robot has traveled. But if those are slipping or they skip some wheel revolutions because of whatever reason, our product can tell you whether your vehicle has actually moved or not, or whether it is actually rotated on the spot or not. So in that case, it's also sort of a redundant sensor for your robot system. Next to that, we can provide some other vital information, such as the inclination of your robot. It can tell you whether the robot is stable or not. It can tell whether it's about to fall over, which is, of course, the worst that can happen. But it can also tell you information about the state of your vehicle, like if it's heavily loaded, or if there's a broken wheel, or it's facing a lot of shocks or vibrations. You can measure that using our products. In addition, if you're working on outdoor robotics, then of course we can also combine this with GNSS data for absolute outdoor positioning. All right, with that introduction said, let's have a look at our entire portfolio. Now, Mehdi has already introduced the different functionalities that we can offer. You can find those on the left-hand side of this slide. And for each of these functionalities, we can provide different hardware versions. And we summarize those as the MTI 1 series, the MTI 600 series, and the MTI 100 series. And recently we have included a vision-based product in our portfolio as well, which is called the Xsense Vision Navigator. If you would like to learn more about these products, there's the links, or the product codes on this slide are actually links to data sheets and product leaflets. And we will share this presentation afterwards, so you can really look at the specifications of each of these products. But for now, let's focus on what this webinar is about, and that's the MTI 320, which is bordered in green on this slide. The MTI 320 is an active heading tracker device, which means that it provides roll, pitch, and heading information in addition to fully calibrated IMU data. And it is part of the MTI 1 series hardware. This means that it uses the sensor components of the MTI 1 series, but we have seen that, especially in the mobile robotics market, there is a need for plug-and-play modules, which is what the MTI 320 is. All right. So on this slide, we can see the technical specifications of this new product. You can see the actual module on the bottom right with the coordinate frame indicated as well. The MTI 320 is built on top of our Kalman filter. This Kalman filter has been developed for many, many years within our company. And what it basically does is internally, it samples all of the sensor data at a very high rate, at 1 kilohertz. It synchronizes all of the sensor data and processes all of the data in order to produce the best possible orientation and IMU data. We achieve a roll pitch accuracy of 0.5 degrees RMS, and the yaw value, which is unreferenced. So we cannot provide an absolute error for this parameter, but we try to keep the drift as low as possible. So if you've worked with IMU products before, you know that gyroscope data, or actually integrating gyroscope data, will result in drift over time. We try to keep that as low as possible by using our Kalman filtering, but also by using additional features such as our active heading stabilization algorithm. And I will touch more into that on the next slide. Internally, it uses a 3D gyroscope and 3D accelerometer. The full scale range is mentioned here. And there is also a 3D magnetometer, which isn't used to identify where the magnetic north is, but it can be used by the active heading stabilization algorithm. And of course, if you would like to read out the data and use it for your own purpose, you can always do that. The MTI 320 has a standard RS-232 interface, and we also provide a starter kit, which allows you to connect over USB. And finally, the output rate is fully configurable, so you can choose between 1 to 100 hertz of data. And for those applications that really need a high output rate, we can even provide up to 1000 hertz for acceleration and rate of turn measurements. If you want to know all of the technical details like voltages or installation requirements, you can find those in the data sheet, and the link is at the bottom of this slide. Okay, so I shortly mentioned the active heading stabilization feature, which is really a feature developed here at Movella. And let's take a step back. Why do autonomous mobile robots, but mobile robotics in general, why do they need such a feature? Well, they are often used indoors where there are lots of metal objects and magnetic disturbances present. And that means that AHRS navigation is a challenge. So you cannot really rely on your magnetometer for indoor heading referencing. On the other hand, as I already talked about, purely relying on gyroscope data will introduce a drift over time. And this will just be building up over time. So that's definitely undesired. We've come up with this active heading stabilization algorithm, which is running in the background continuously. So you just either turn it on or you turn it off. It's up to you to decide. And what it does is it is going to look at the magnetometer data, not to use it as a compass, but to stabilize the yaw output. And I cannot really go into the details here because it's our algorithm, and of course we don't want to tell everybody about it. But we have seen from our own experiments that this really drastically reduces the drift of yaw output. You can see a small example here on the slide in this plot window. where we have taken two MTI 320 devices together with a competitor product of the same price. We put them next to each other on a ground vehicle, and we've been driving around this ground vehicle for about 10 minutes. And what you can see is that at the end, when we came back to the same orientation as at the start, the two green lines, you cannot even distinguish between them, but both of them end up near the 0 degree again. So it reaches the same orientation again, and it means that it has been successful in tracking the yaw angle throughout this experiment. Meanwhile, the competitor product has been drifting all the time, and it's approximately at minus 50 degrees. If you would like to learn more about active heading stabilization, we have a whole article about it that you can read on our knowledge platform called Base. And in addition to active heading stabilization, you can use some further features that we offer, such as manual gyro bias estimation, to further improve the stability over time. For instance, with manual gyro bias estimation, you are basically telling the device to recalibrate at moments where the vehicle is standing still. But you can also use our software in such a way that this happens automatically when, for instance, your controller of your robot knows that the vehicle is standing still. Also there, we offer a article which you can read through, and you can find it on our knowledge base. Okay, so in summary, we've been talking to various vendors or constructors of indoor robots, and what we've identified in the market is that there is a need for roll pitch data at an accuracy of about 0.5 degrees, and especially the yaw angle or heading angle is important. They should be as accurate and reliable as possible when you're standing still, but also when the vehicle is continuously in motion. Meanwhile, outdoors, we can also provide position data. With RTK, we can provide it at centimeter level accuracy, which is important if you're navigating through narrow spaces, for instance. So with that, we think that we can really provide the right IMU or AHRS or GNSS INS products for your use case. What else comes with these products? Included with our products is also our software package. It's called the MT Software Suite. This is free to download from our website. You don't even need to have a product already. It doesn't require a serial key, for instance. So you can find it in the download sections of our website. It includes a graphical user interface called MT Manager, which you can simply use to configure your device, to visualize all the data, and to record or export all the data. It also comes with a MT SDK with an open source API, and that includes programming examples for various programming languages, so you can really get started and integrate it quickly into your own software. For those of you that are using ROS for your software management of all the sensors, we provide a ROS1 and a ROS2 driver. Finally, there is a firmware updater such that you are always using the most up-to-date firmware of your devices. And there is also a magnetic field mapper or magnetic calibration tool. This is not really designed for the MTI 320, but if you're planning to use an AHRS product where the compass-based heading is important, we provide calibration tools that allow you to compensate for magnetic disturbances of your vehicle. Next to that, if you are thinking of starting off with one of the MTI series, we offer development and starter kits, which make it as easy as possible to simply connect the device to your PC and get started with your prototype as fast as possible. So it includes all the necessary cables, USB converters, antennas, etc. On the right-hand side, you can see an overview. Oh, I didn't do that. So on the right-hand side, you can see an overview which shows all of the available starter kits and development kits. So for each of our MTI products, there is a starter kit or development kit available that covers this functionality. Finally, last thing that I wanted to add is we have actually written an application note on integrating MTI products into mobile warehouse robots, but in general also for all kinds of mobile robotic applications. So you can find it on our documentation page. It once again covers all of the MTI functionalities and the products that are the best fit for this use case. It covers best practices, both on the hardware and the software side. It even includes some sample data. And finally, it touches on some modifications which you could make to your ROS driver to optimize it for this type of application. Okay. We're finalizing this webinar with a list of some links. I guess you can't click them right now, but once again, we will share this presentation afterwards. So if you are in need for further information, please click on the links, contact us for more information. We even have a video reel on YouTube, so that's nice to see as well. And we have our own LinkedIn feed, so you can also subscribe to that. And with that, I think I want to end this webinar and say that we are open for questions. If you haven't done so already, please send in your questions via the questions tab. So not via the chat app, but via the questions tab. And then I will go through them and raise them either to me or to Mehdi. So let's see if there's something in there already. Yes, we actually already have some questions coming in. The first question that I can see is, how about the use of the firmware updater in an embedded application? Well, that's a very good question. The firmware updater, which is part of our MT software suite, that's a Windows or Linux tool. So in that case, you would need to be able to connect your MTI products to your PC. And that can be done via a serial connection or via a serial to USB converter. So if you're designing in your MTI products into your application, then it is best to make sure that you can always access this serial or USB interface. Alternatively, if you are working with the MTI 1 series product line, which is really this embeddable module which you can solder down onto your PCB, we also offer a SPI and I2C embedded firmware updater program for that. So you can find those in the MT SDK folder of your MT software suite. Then I got a question which is specifically about our GNSS-INS products, the MTI 670 and MTI 680. The question is, what is the difference between these two products when using an external GNSS receiver? And then what's added is the NMEA can also be used for RTK receivers. Good question. The MTI 670 and MTI 680 are indeed both products which can connect with an external GNSS receiver of your choice, basically. The difference between them is that the MTI 670 is designed for a standard precision GNSS receiver, so meter level, while the MTI 680 is designed for high precision or centimeter level GNSS receivers or RTK GNSS receivers. It's simply that the algorithms that are running on the 680, those are made capable to work with this high precision position data. Okay. Another question is, does the MTI 680 also have active heading if it was to be used indoors? The MTI 680 is, like I said, a GNSS-INS product, and that means that it is in principle designed to be used outdoors. You can move indoors with an MTI 680. It will continue to provide orientation and IMU data, and for a short duration also position and velocity data. But we cannot guarantee that it will perform as good as it does outdoors. If you're really working on an indoor use case, then I suggest working with the MTI AHRS or active heading tracker modules. Then there's a question for AGRs for indoor. What type of technology do you recommend? So the MTI 320 is an active heading tracker module, and that's really what we recommend for indoor usage to make sure that the compass functionality of the device doesn't get disturbed by magnetic disturbances indoor, while still providing roll, pitch, heading, and IMU data. Our GNSS INS products are not really meant to be used indoors, except for the Vision Navigator products, which can go from outdoors to indoors while still producing position data based on the camera information. There's a question about the MTI 670 and 680 again. Is it possible to integrate an external RTK receiver with heading, so 2 GNSS antennas? Unfortunately, that's not possible at the moment. Well, you can connect the external GNSS receiver to these products and connect 2 antennas to it. However, the MTI 670 and MTI 680, they will not take into account this heading information from the GNSS receiver, at least not in the sense that this is a dual antenna GNSS receiver. So this functionality is not yet available. On the other hand, our Vision Navigator products does already include a dual antenna GNSS receiver. I see another question. Will the new sensor be compatible or useful with any kind of Movella Xsense mocap suits, like putting it on a sword for better accuracy? That's a very good question. It is not directly compatible in that sense, so you can't connect them to each other, but of course you can always try to use them next to each other. Where the MTI 320, for instance, will then still provide you with roll, pitch, yaw, and IMU data. But if you're considering such a use case, it might be better to look at our other products. So we have also wireless motion tracker products such as the Xsense Dot or the MTW Winda. Those might be more suitable for body motion applications. Then there's a question, you show RTK input. Aren't your modules providing that? Yes, so the MTI 680, for instance, or the MTI 680G, those are RTK GNSS products. Those are able to take in RTK correction messages to improve the positioning accuracy. The RTK corrections need to come from an external base station that is near you, and that's not something we can provide at the moment. So you will need to find a base station or install it yourself, and then it's basically your responsibility to make sure that those corrections are sent over a wireless link to your MTI to the internal GNSS receiver. I think I have another question for Mehdi over here. So I think I'll switch to Mehdi. Mehdi, do you offer introduction discounts for the starter kits?
Yes, we definitely provide introduction discount for our starter kits. And the way to apply for it, basically you have to have a meeting with our one of our account executives. It can be an online meeting. And to request for that meeting, you can send a short email to sales@movella.com. Again, it's sales@movella.com. So to set up a meeting with our account executive to get a discount for the Escape type of products. And also I see another question that it says, do you have already a success story with this product in AGV AMR market? And the answer is yes. Many actually big players in this AGV AMR market has adopted our solutions. And, we have already have many global implementation of our devices in this type of application.
I think I see some new questions in the questions tab. So one question is, does the XVN use the 320 for its IMU? No, the XVN uses a different type of IMU inside. I can't really tell which IMU that is. Then there's a question, do any of the 600 series products or XVN output the current IMU bias estimates? No, so with the MTI 600 series, we do not output the bias estimates. Those are continuously estimated by the sensor fusion algorithm, but it's not something that is available to the user at the moment. I think for the XVN product, that's the same. There's a question whether the MTI 320 is preferable over the MTI. I'm sorry, I'm not fully understanding this question. But yeah, each of the MTI products has its own functionality level and hardware version. So the type of MTI product that fits best with your application really depends on what kind of system you are working on, what kind of performance you need, and what kind of size, for instance. If you would like to have a talk with our team about which product best fits your use case, then please get in contact with us. We can run through a presentation and discuss each product in more detail. I see that there's a comment to that message now. So the question is the MTI 320 or the MTI 3. So whether those two products are different or if one of them is better. So the MTI 320 and MTI 3 are similar in terms of performance. However, the functionality is different. The MTI 3 is an AHRS model, so it provides you with magnetic heading as well, so north referenced heading. And the MTI 320 does not do this. So if you are in need of an absolute north referenced heading, then the MTI 3 is more what you're looking for. But if you're if the reference of the heading is not important to you, so if it's just if for you it just matters what the rotation is with respect to the power up moment, then the MTI 320 might be a better fit. Okay. There's a question. We are trying to do dead reckoning on a ground vehicle, both indoor and outdoor, with a wheel encoder attached. Which product is more suitable? In that case, I do recommend looking at the Vision Navigator product, because one, the Vision Navigator is able to take in wheel encoder data. So it uses that and fuses it into the sensor fusion algorithm to continue outputting position data. And in addition to that, the Vision Navigator is really a product that is designed to be used both outdoors and indoors, where indoors it navigates based on the camera and outdoors it navigates more based on GNSS data. Let's see if there is any other questions. I don't see any new questions, so I think I'm going to close off the this webinar. I'm going to hand over to Mehdi. I'm not sure if Mehdi has anything, any last comments to make.
Thank you. I just want to thank everyone for joining us. This is very important to us. You invested your time for the last 45, 46 minutes listening to us. Hopefully that was beneficial to you. And I hope you follow us on LinkedIn. And also the best thing is to use our devices in your applications. So with that, I just want to say have a great rest of your day, and hopefully we'll be in touch. Thank you.